Hey everybody, Brian again, back again with another Java tutorial. Tonight, I thought I'd look at a problem out of Building Java Programs version 3. I'm looking at problem number 8 on page 379. This is a chapter 5 problem, so you can refer to your textbook for that. And pause this video maybe if you want to try a solution before I do. Again, this is another video where I haven't rehearsed a solution yet, so you'll get to see me in live problem solving mode, in which case, I may not write the most elegant, perfect solution, and I may kind of mess up on the way, but, it's kind of cool to see other people go through that. So I'd like to model that process for everybody. So let's go ahead and read this here. We're going to write a method called random walk. I'm transcribing this from the book. That will perform the steps of a random walk, one-dimensional, which begins at 0. Each step should either increase or decrease the position by 1, determined randomly. The walk continues until a position of 3 or -3 is reached, in which case the max or min position is reported. Okay, so basically we're like, if I can kind of like model this with the mouse, right? We have like this number line. I'm just gonna like kind of visualize this. I haven't really even thought about this at all yet. 1, 2, and 3. So we're kind of here, and we're going to be like here and randomly kind of like bouncing back and forth until, we finally reach here, at which case we will report the minimum position that we were at, which I think what I just did was right here. And if we randomly walk and end up getting down to -3, then I would report that 2 was my maximum position. And I probably want to print where I am after each step as well. All right, so this is going to be kind of challenging, I think, and very likely that I won't write the best solution, but it's okay. I'd love to see your comments, especially if you see something you can improve or make more readable, make more elegant. Let's go ahead and do this though. So it's going to be public static and void. I don't see anything I need to return. Let's call it random walk, like they suggest. Okay, no parameters needed. Okay, so I'm going to think about all the things I'd like to keep track of. I'm going to keep track of the current position. And it begins at 0. I'd like to keep track of the current max position. I'm going to say that's also 0, and the current min. And I'm going to print one of these two at the end, depending on if I hit the the -3 or the 3. I'd like to keep both of them just in case. Okay. So let's see here. I want to step. Okay, so step randomly to either left or right. Okay, so now I need to create a loop, a while loop. Okay, so I'm going to step forever until I hit one of those points, right? So while the current position, if I can get a shortcut, while my current position is not equal to 3, and my current position is not equal to -3, then I want to continue to step. Okay, so this is pretty critical. I'm just going to keep looping through, and the loop will exit. So step randomly in here. And update, update the max and min if needed. Anything else? I don't think I need to do anything else in that loop. At the end of it, I'll come back and fill that out in a minute. At the end of it, I would like to say if the current position reached, or if the current position, I suppose, were 3. Current position, which is where it's going to be ending, right? This is where it ends. If it's going to be 3 double equals, then I'd like to report the minimum position, right? Can you remember that little visual I did? If we hit the far right, obviously, the max is 3. So it's more interesting to print the min. So I'm going to print that. Min position was, and then I'll append on the current min. Okay, let's see. Just a little bit too big a text. So I'll append on the current min. Otherwise, then that means the only other condition that would get me out here is if the current position was was -3. So then I want to print. So I'm just going to like basically take this exact thing, change a few things about it. Max position. So I kind of we're making sort of like an assumption here that if it's not 3 that got us out of the loop up here, then it must have been -3, right? So, oops, -3. So, maybe not quite so readable, but, I think it's pretty clear that if it weren't 3, that it's -3. So you could say else if it's a -3. But I think I'm just going to leave it like that for the sake of time. All right, now it's time to determine the random steps. Okay, so let's use a math.random, and basically I'm going to split it down the middle. Math.random goes from like 0 to 0.99, so I'm just going to split it right in the middle where it's like from 0 to 49 is one step, and from 50 to 99 is the other, right? And of course I mean from 0 to 0.49 and from 0.50 to 0.99. So I'll split the math.random into 2 categories and step either left or right from there. Okay, so every loop I would like to determine random equals a math.random. Why am I saying int? Come on, man. It's definitely not an int. I'll fix that. It's a double. Okay, so let's go ahead and say if this double is less than 0.5, that will be step to the right. So current position plus plus. Spelled it wrong. And otherwise, so if it's not less than 0.5, then the rest of it on the way up to 1.0 will be a minus minus here for current position. Current position minus minus. So I have a little bit more work to do inside here. Why did I say double? It's the random that I'm interested in. If the random is less than that, when I increase the current position. Otherwise, I'm going to decrease the current position. So if I increase the current position, it's possible that current max may be overcome. Okay, so if current, so inside here, I need to kind of write a different one. I need to write a sub if statement. So if right here the current position is greater than the current max, I need to update that max value. So I'm going to say current max. Hey, guess what? You have a new number now, and it's where you are right now, current position. All right, so now I've increased the position. It's possible that at that point that it is the new maximum that we've ever gotten, right? So if that's the case, if the current position is greater than the current max that we've observed, then current max now has a new value. It's current position, okay? And if not, then it'll just kind of like leave and, perform another step. So let's borrow this logic and do the same thing, but in the reverse way. If current position is less than current minimum, then the current minimum gets the new value of the current position. I think we're pretty good here, but I think I'd like to print the step. We already did that. We already updated min and max. So now I want to print my location. I think we're doing pretty good on time here. Hopefully this is nice and clear. Remember, questions, comments, and stuff will be promptly addressed, so please leave them for me. So let's go ahead and print. The current location is current position. All right, that should be solid. And then, okay, so we're stepping, and it will leave the loop at the right time. If what got us out was 3, it'll tell us what the minimum was. If it got out as a -3, then the max position will be printed. Okay, so let's go ahead and run this. I have 30 seconds left, so really hope I don't have any errors. So let's call this and see if I can write the call, random walk, and observe its behavior all in 20 seconds or less. Okay, let's see. Oh, that's pretty lame. It didn't really like step very randomly. There we go. That looks better. Okay, I guess that worked. Talk to you guys later. 1 second. Bye.